because I'm going to eat my salad. You salad eater.
Right. Yeah, think I'm live. Right, that'll do.
Wide awake, I can't really hear you. I'm not sure if you're talking to someone else or not.
Right.
Is that better?
Yeah, that's better.
All right. I had to move my camera.
Yeah, that's cool.
Yeah, we had another call for Jesse. Was the thing I was when we were over at Gems earlier? We were asking again. You know, they don't like the conversation about level and horizontal and all that. But they say plenty of other people have actually measured it, but when asked, they only ever seem to come up with one name. It seems to be the only person that they know that's doing it at the minute, and they are really struggling to when they are pushed. We did talk about, somebody said that Soundly was one of the ones that had measured the curvature for them.
Wow, this is really awesome. I just have to say we have a geometry guy, an optics guy, and a surveyor right here together. This is cool. Yeah.
Right, so I'm just trying to look now for Jesse's what was it, the lake? I can't remember, what was it called?
Jesse Kozlowski, Soundley's Bridge, or utter nonsense. I'm not sure what they called it.
I'm looking for it.
Utter.
Oh my God, is Rumpus here?
It sounded like him.
Please, Rumpus.
Oh, there we go.
Turn
Perfectly flat level lake. Now this has been done. Did we do the 1 mile level line?
1 mile level line.
That's the one that we did, was it? I think.
Yeah, I'm trying to remember which.
Seconds.
Is that a Kozlowski one?
Yeah, that was the Jesse Kozlowski, because this is in his series of videos.
Oh, yeah,
this is the
yeah,
one
yeah.
that came before it.
I don't like that one because when I took and did the elevation profile on Google Earth, it's a damn valley that he was working in. You know, from high point to high point, down through that, doing reciprocal leveling, and never once told you what he was doing. Never, you know, all he did was just insinuate he was measuring curves somehow. Very, very ridiculous.
Well, I've got the video up, and your one is showing on my recommended, so that's handy, isn't it?
Wow, that's cool.
Yeah.
Yeah, Cleary, I just got recommended your video as well on YouTube.
I like
Sweet.
it. YouTube
Probably because you
been
made
good for us.
Probably because you made my thumbnail primate.
Oh, but is that favouritism then? Is it?
Yeah.
Right.
Yeah, I
So,
like that.
Did anybody see the last video Dr. John D did?
yes.
Awesome visibility he had that day, because there's a landmass that's farther back in his footage. I asked what was it, and I didn't get an answer yet, but
Well, you know why Dr. John isn't going to give you an answer, because basically it doesn't really matter what the landmass is. By you talking about the landmass, you are taking away from the observation that he's got there. But where he's looking, there's only one landmass that can be. And it's not in the UK. It's a different country.
yes, I believe it's France.
Yeah. So
that should be impossible at the height that he was.
yeah.
Hang on, he's in France from Worthing.
I don't think it was Worthing. We went to go and look at some windmills, but you know, sort of like that one that I did with my lad. and we went to, and you can sort of line the windmills up so you end up with a perspective shot.
Right.
That was that was some phenomenal conditions. Or they're not that far away. I think the windmills that me and my lad go and look at, we'd struggle to get a shot like that. But well, I'd love to get it. I mean, we keep going there for it. Yeah, you should have a look at that. Yeah, there's a little bit of land in the background now. The ballers are going to want to take the conversation about that bit of land when the conversation isn't about what the bit of land is in the background. The conversation.
No, it really wasn't. It was about the distance to the turbines. The farthest one away was, I think it was 11 miles. And then there was also a boat that was beyond the farthest windmill, and it had to be a lot farther away than the windmill itself.
Yeah, we had some pictures of the windmills. When I went looking and researching them, they said that for the windmills to be most effective, because of the way the wind goes through them, the airflow, they leave, I can't remember, it was 11 or 17 times the span of the blades, and the span of the blades is like 250 meters or something. So they on average they're about a kilometre apart, them windmills, because boats sail in between them.
Interesting.
Yeah.
It's madness, isn't it? I mean, you look at them; they don't look a kilometre apart.
No, I mean, if of all of the things that seem to look magnified in the distance, the windmills always seem to. I mean, I know we have P1000s, but they just look they look a lot bigger than you'd imagine. But I mean, I've never been out there and seen them on the sea anyway.
How do they compare size-wise to the ones on land? Because I know they come in
a lot bigger.
sizes. I mean,
They're massive.
Yeah.
yeah. Because I was the year before last, I was driving all the way across Europe through Germany up to Denmark to the Czech Republic. I was doing a lot of driving on the continent, and in Germany, they've just got fields and fields and fields of these wind turbines, and you'd be surprised how many different shapes and sizes, and there's not a standard to them.
I know a guy that worked on the windmills, like all over. I don't know if they flew them all over the place, but he said that the what do you call it? The fins,
The blades, yeah.
the blades are like, I think some of them are 500 feet, like the ones out in the ocean.
Mm.
Yeah.
Some ridiculous amount.
Yeah, that's where I was getting my numbers from for the, for the distance between them to be efficient, so they don't end up cutting the air from other ones.
Yeah, I asked them about that too. They have to be a certain distance away from each other so they don't interfere.
But I did see Ranty do a thing where he showed that they're all positioned and you can mark it all out. I'd never seen that before, so I want to go and have a look for mine, see how far away they are. Cause
I also heard that the blades are actually moving so fast that they'll slice a bird in half. Like they'll just obliterate whatever. But they look like they're going super slow. But they're so massive that the speed is actually like really fast. I think like 200 miles an hour or something like that.
I was talking to a guy last night, and he said we should have like 100,000 women marching for flat Earth. I said, "Damn, that makes a lot of sense, because if Mama ain't flat, ain't nobody flat." You know what I'm talking about? I was just like, all the people in my chat are female, and Emma's female, and Globeheads hate females. But sorry, I don't mean to.
No, they do. They do.
That's funny.
That's because females
Every
have
time-
more common sense than males.
Yeah, that's right.
Apparently so. Yes.
Although I can't change my wife's mind. She won't even look at my stuff.
She must like NASA.
Yeah.
Oh, yeah.
Yeah, I haven't had any luck with getting my wife to look at flat Earth stuff either. I think it's probably because she's a teacher.
Yeah, she knows that she would be conflicted then.
Try not to push. It's the last thing that you want to do is push.
Yeah,
No,
absolutely.
I don't. I leave it alone.
Happy wife, happy life.
That's right.
Yeah, we've been together 20-something years for a reason.
Yeah, I'm 38.
Sound a lot older than that.
I'm 31.
No, I said I've been married for 38 years.
Yeah.
Oh.
Okay.
Yeah.
Oh, okay.
Wow. That's different.
That's lovely. Congratulations.
Thank
yeah,
you.
that is. That's rare. That's what that is.
Yeah, especially when I got married at 19, so a lot of people my age have been divorced many times before.
Yeah, if you want to live forever, get married because every day seems like a fucking eternity.
Oh, Paul.
Holy.
Nice one.
That's truth.
Yeah.
And I love my wife.
We all do, otherwise we still wouldn't be with them, right?
We'd be globeheads.
You can't live with them, and you definitely can't live without them.
Can't shoot them.
Yeah,
Women.
no. They're better
Women
shot.
seem wicked. Yeah, women seem wicked when you're unwanted.
This is
Faces
kind of a
seem
weird
ugly
conversation. To be
when
fair.
you're alone.
It's my
Is it a
fault.
weird concept? Yeah, it's Clary's fault. Blame Clary.
But Turnip took it into a whole different direction.
Oh, of course, yeah. You're right back to my fault again.
Uh,
So long distance photography. This is where somebody's supposed to.
We're looking at here.
Yeah, I'm the long distance photography guy.
Oh, ours, yeah.
Well, I've put.
Yeah, I've spent 4 years out there trying to. Well, I got involved because I wanted to debunk flat Earth, and about 6 months into it, when I got my first good day of visibility, I was like, "Wow, it's obvious when you get a good day of visibility compared to a bad day of refraction or diffraction." Whatever you want to call it, because the clarity is just it's there. When you get a clear day, you see things much clearer, and you're not getting that mirroring, miraging, or there's another word I'm trying to think of. I'm just haven't had my full cup of coffee yet.
I
Refraction.
thought you were wide awake.
Yeah, not quite.
Not
Ish.
quite wide awake.
Yeah.
not until I have all my coffee down.
Wide awake-ish. I'm going to have to do an On the Level Wide Awake t-shirt, aren't I?
Yeah.
Yes, you are.
That would be cool.
Yeah.
Yeah, I don't know. Perspective compression, refraction effects. Yeah, it's a lot of stuff going on at the same time.
Yeah, that was the word I was looking for, Clary. Is compression. I see compression beyond the Bayport Bird Rack, which is 3.5 miles away from me on an average. And sometimes I get boats that are compressed way below, or it's like it's behind it, but it's like the water line is compressed down at the bottom of that rack. And then on a good day of visibility, I've got boats going above the rack, actually, or the sun setting above the rack, not below it.
Mm-hmm.
Which tells me that there's definitely optical effects that are occurring that are either displacing objects that are beyond that rack. And I'm normally not even at 6 feet when I'm observing the Bayport bird rack.
Yeah, I think atmospheric light extinction is occurring in that high refractive medium there. You know, at a certain point, you're just kind of looking at a wall of water vapor that you just can't see through.
Oh yes, it gets illuminated by the light too. Light, angle of light. I've gone from where I set up at Pine Island. I get a good view to the south and to the north, and I can see the difference between north and south. And straight out in front of me, sometimes you can see how it starts mirroring as I move to the south, and boats start appearing to be cut off at like 4.8 miles, where I move out toward my west, and I'm seeing boats that are 8 miles out that aren't being cut off. So how is that? It has to have something to do with the angle of light hitting the water, or the water temperature could be different coming out of off the land, because most of these the water coming out of off the land is a lot of times spring water, so it is much cooler water flowing into the Gulf.
Yeah, temperature differentials and difference in saline content, like the thermohaline cycle.
Exactly.
And then the continental shelf diamagnetic effect as well can create some distortion there too, I'm sure.
And I've got a good location because our water, I don't have really deep water immediately off my coast. It's on an average, you got to go out. It's a drop of about a foot per mile. So if you want to fish in 25 foot of water, you got to go out 25 miles.
Mm-hmm. Yeah. So basically, yeah. Go ahead. Sorry. Yeah. It's real shallow all the way out. Mm-hmm.
Yeah. So on real calm days, and like I say, these dead tides, when the water stops moving and it's very calm out, that's when I get my best observations. And I started noticing that as I go through all of my footage, and I look at the dates, the times, and it's pretty obvious to me. It's curvature is optical. It has nothing to do with real curvature.
That's right. It's perspective compression. They, like Nathan Oakley said, they hijacked perspective and called it Earth curvature. But basically, what you have been able to do through your vast amounts of observations over the past 4 years is basically realize that you can't make a long distance observation without some type of perspective compression or refractive effects and massive amounts of distortion that you would never be able to measure through a crosshair. Today we're dealing with these people who are looking out over 2, 3, 6 miles and pretending like they're seeing, drop, when in reality it's just optical effects.
Yeah, like Soundly, with that bridge.
Oh yeah, Soundly's bridge. He owns it.
Yeah, now. That was all optical. I mean, other people have done it on a much clearer day, and that bridge is not curving down.
No, it's a super zoom camera effect. A lot of people do it. I've seen lots of different images like that. It's just a fun camera trick, Yeah, one thing you got to remember about that Soundly's bridge is you can see the tree line, the shore, behind all that bullshit. So, and
Yeah,
then,
even like the documentary that they had on National Geographic where they're going across. I mean, they're saying that the lines on that board they were holding up were vanishing, but yet you could see the shoreline on the other side.
yeah, that's great. All right,
So
Bev. Oh,
for
I'm sorry.
me, they proved it. They proved flat Earth right there with their documentary, but everybody thought it was proven curvature.
Mm-hmm. Yeah, that's crazy. All right, Bev, did you want to roll the tape here? Is this Kozlowski?
This is the lake, perfectly flat level lake.
Oh yeah, I remember this now.
This is the one. Do you want it full screen? Can you get that?
Yeah, that's good.
I don't know. Like I'm not too sure about. I mean, this is I think this is the half-mile lake, so I mean, this is possible for anyone to do this. I just need to. I need to try and do this myself.
Does he talk about the tilt in this one?
I think so. This is the tilt.
Did he do the tilt drawing and the zenith angles and all that?
See, look, he's got his S-wing hammer and he's level. When I seen this, something just didn't look right about that hammer. It looks like it's got a bent head, but I mean that's just to me. I don't know.
I think it's all right. It's that's the way it's shaped right there. I think.
Yeah, I do have one of these hammers.
For carpentry.
Yeah, well, it's not the hook on the maybe not what we have over here.
Yeah, it's like a 22 ounce or something. I can't remember. I used to have one just like it.
But like, so we've got Rodney here now. He's going to look at this lake and these few pictures here, but the level there gives you away. Have you ever used a spirit level and a hammer, Rodney? Ever heard of that?
Yeah, a few times.
This is Jesse doing his 3 years ago. This, so probably early on. When was the this is after the Beeloo. I think, or maybe before Beeloo.
Yeah, that's pre-Beeloo. He didn't
pre-
have quite the
right,
galactic knowledge at that time.
All right, so this was all of his own then.
Hi there.
Mhm.
I just posted this to my data blog. This one's called "Looks Perfectly Flat and Level to Me." This is another lake test. You may have seen the video that I posted around 8 days ago of the results
2016.
that I collected and analyzed here on Union Lake in Millville. And that video is called Flat Level Lake Measurements, using the lake as a level to.
Right, so he called that one flat level lake measurement. I mean, this is very early on. Do you reckon he'd get away with that nowadays? It's a bit of a giveaway, that, isn't it?
What's the distance there?
Sorry?
What's the distance?
I'm not so sure on that one, but I think the one that we come up with in a minute is a half a mile. That he's looking over. I don't know about that one because we never looked at that. Only 69 views, so it looks like not many people had looked at it.
Points that would be a level with each other, using the water surface to do that. And this turned out real well.
Looks like some of my observations.
Yeah. Well, he says he's using the water level as a thing. I mean, we've been told we can't do that. Interesting.
Not very dramatic, but it showed me, this was worth pursuing. So I went ahead and I went ahead to this location along the Cooper River, which this area is called Cooper River Lake because it's above a dam, and it is not tidal anymore. The water does rise and fall a little bit here and there, but
right now, I don't know whether you can see this, but he's knocked a nail in, and he's leaving that. I mean, it says it's 60 mil. I'm not even sure about that. If you look at where the bottom of it is, it's not on the water. It's on a rock at the side of it.
basically it's just
See
a
if you
level
can see that.
lake. And as you look at what I'm going to post and show you here, you'll find out that that's what I found out. It's actually level. And what was nice is that I had a much longer line. It's over a mile. It's about a mile, 1.38 miles.
Oh.
It's 7,311 feet, this line. And I set points at either end, at the eastern side and at the western side. And I'm going to show you that. What I did is I just set a spike, a nice long spike, 60 millimeters above the water. Then I set another one
I have to
back
go
from
back
that
there because he does say it's above the water.
I have a question here. So he said this is him setting a point to work from?
I think so, yeah. He says this is his base mark, I'm guessing, which he says this is 60 millimeters above the water. Well, it's above the top of that stone there, but the water doesn't look like it's at the top of that stone, so...
Yeah, he's not going to have an accurate starting point.
Yeah, that's how he's setting it off, and then he's going to use the level from there.
Bev,
yeah.
Are you sharing your screen on your live stream because it's showing different stuff?
Oh.
You got like images running on there.
Oh, right. Yeah.
Sorry to interrupt.
Thanks. There you go. I'll turn his DP's pictures off as well.
Those are great pictures, but
yeah.
I'm looking on my screen. I'm looking at the 60 mil nail at the water edge.
Yeah.
Yes, that's what I see too.
Yeah, but it's not. You can see it's not. It's not 60 mil at all, is it? I mean,
yeah, those images are still rolling through there. Oh well.
Yeah.
Are they?
It's too small for me to see the actual numbers, but yeah, all he's done here is just measured the height from the top of the rock to the top of the nail.
Yeah, and said the water. So we'll carry on, right? So this is how he's setting it up, anyway.
Then I set another one back from that about 3 feet, just using this little 3-foot carpenter's level, and made sure that it was level. And you can see.
Right, so we needed 2 for some reason.
See that here?
Yeah.
So this is the point that I'm referencing to the water, 60 millimeters, and this is the point that I'll be occupying, and they are level with each other. So, I mean, this makes sense, certainly, right? So I did that on...
Did anybody get the idea of that? Did you?
I don't know, Rodney. What do you think?
It's not this one here because the water wasn't like that. So it must have been the other one. Is it this one? There he was looking at. But I mean, I don't know what they were doing that for. Honestly, he's
leveling those 2 points right there. He's measuring the height above the water
badly, and getting it wrong, and then he's measuring it, leveling another one about 3 foot further away.
Mm-hmm.
For some
I'm not
reason.
sure what he's I'm not sure what he's trying to do here. I'll see what goes on, I guess.
Okay, here we go. Oh, that's him. There seems to be a lot of work about this, sorting his nail out and getting that level.
What was his quote? The water level drops away from the horizontal.
Flat level lake.
Yeah.
That's a bit
Yeah,
scummy,
flat
that.
level lake is flat level.
Oh, there's another nail there. There's like a. You'd think that these are pretty important, wouldn't you? These. Okay. Oh wow. I don't know why this bit would need filming as opposed to the rest of it. It's like somebody spilled some paint or something.
And then, of course, I'm showing you how I set up my targets.
Right. I have another question about this, Rodney. Is this how you measure a height?
No, not at all.
And why would you be measuring a height of this? I'm guessing he's got the nail right underneath the center of this, and he's then put that on the nail, and then he's measuring this height for some reason.
Is this an auto level that he's using?
No, I think it's a theodolite. Look, he's got a Trimble scope thing here.
Trimble, okay, yeah, so that would probably be a theodolite.
Yeah. But yeah, we make a note of this. This isn't a vertical height measurement, is it?
No, that's a diagonal.
Yeah, that's pretty bad. You're at least going to be maybe 5 or 6 mil out.
Probably more than that.
Yeah.
If the theodolite is directly over his mag nail that he set, and he has that ruler on the mag nail and leaning it that far out, I mean, he's probably having to lean it to the side.
Yeah.
4, 5, 6 inches probably. I don't know how much that's going to throw the reading off, but it's not going to be accurate.
But I think that's what he's doing, right? I think he's measuring a height of the theodolite and a height of the target after nailing his nails in. We'll carry on though. I mean, I think that's what he's doing.
Measuring to the notch here. It's a very precise measurement.
Very precise measurement. Did you hear that? That one there, measuring to that notch, is a very precise measurement. And
I call these points Cooper 2 and Cooper 1 with the date. Here's a measurement from the notch to the center of the target.
yeah, we're just live going over Jesse at the minute.
What's up, Spot On? We're on YouTube, yeah.
All right, thanks.
Add these together, you end up with a true height of 1.613 meters. So there's the target at point 2, aimed and looking back at point 1. All right, so now I'm going to go over here to point 1 and assure that the telescope is set at the same height, and make sure that the instrument is very, precisely leveled.
Looking down at the thing.
Before making the observations.
That's not how you get an instrument height.
Well, if you watch what he does, he goes off and he has this one here. So I don't know what is this. Because this says to me that some sort of equipment. And then he goes down to... this one here, which is his the site of the target. And then we're on to this, which, I mean... That looks like 3 different pieces of equipment to me. Would you agree?
Yeah, it kind of did to me too. It looks like he's just trying to establish the height of his instrument, but I don't know why he's going about it in this way. I mean, the way you would do that is start with a known control point with a known elevation. Set your instrument up, a distance from that, and shoot back to it to see what your reading is on your grade rod, and then you would. That's how you would do the math and get your actual instrument height.
Yeah, you'd be looking through the scope of your optics to a known benchmark, and you would be reading a number from the hairs to your to reference your datum, right? That would get your starting datum. All of the nails and the measuring the heights of the instruments to me just seem very strange.
Exactly. I mean, you would just say your known benchmark was at 100 feet elevation, and you shoot back to it, and you read a 5.5 on the grade rod. That tells you that your instrument height is 5.5 or 5.5 feet.
Yeah, I mean, our auto level can see as close as possible is 0.4 meters. So all I do is set my auto level up. I bang a nail in, so it's right on the level of the water, and then put my measuring rod on the water and sight it through my through the auto level, and that would be the height that the optics of your start is above the water.
Yeah, exactly. Yeah, if he had put the Magnell level with the top of the water and did it that way, that would have worked.
Yeah. So yeah,
he's going to be all out of whack though.
It does seem a little bit strange. Yeah, it's good to have you here, Rodney, because otherwise I'd be saying this and people would be just go and have a look at how a surveyor would work, and I suggest it isn't like this. But again, we are open for Jesse to come and have a word with us, and he can explain it. Perhaps it may be different methods that we're not used to. I'll carry on anyway.
So there's the target at point 2, aimed and looking back at point 1. All right, so now I'm going to go over here to point 1 and assure that the telescope is set at the same height. Make sure that the instrument is...
Is he possibly saying he's got 2 telescopes? Is that why we're getting a lot of people saying that there's 2? Is he doing a reciprocal? Maybe.
Yeah, like 2 telescopes aiming at one target.
No, what at each end of the lake, looking at each other with a target. I don't know. He's took 2 different measurement heights for 2 different optical units. That's all I'm thinking of at the minute.
Very,
I don't think it becomes that clear.
Making the observations. And then here I snap a shot through the telescope with the telescope set to be horizontal. And there's the target. It is definitely below the horizontal crosshair.
I can't really get that much of a thing. It looks like it's above it to me, or does he mean that the crosshairs are below it?
I thought he said the crosshairs were above the target.
Well, that little white bit there looks above, but I mean, I can't tell what is what really. That's really.
No. You're not reading the rod or anything.
No.
I don't know what he's looking at.
No.
Yet they are at the same elevation, and this is what I expected to see. I'm reporting it to you here. I'm not, not making this up. This is really what you will see. And I really do encourage people to go and see this for themselves.
See how
this is not
vague
that
he
hard
is? He's implying that you're looking at Earth curvature, but he never really says it.
No, he
This
just
is what
says-
you see.
Yeah, he implores you to go and look for it for yourself.
Mm-hmm.
But he was also off too because his measurement for the target was at a diagonal.
Yeah.
He said they were both at the same elevation, but he had no way to verify that or
Yeah.
check that based on his setup.
We had a nice video of the thing that he was looking at for banging his nails in. But when it comes to this bit here where he says he set it up as horizontal and looked through it, there's no video or anything for that. That's just a picture through the crosshairs. And as we've seen, he has a theodolite. If he'd have had an auto level, I would have had to sort of say, yeah, that is horizontal. But he's got a theodolite that can, as we saw, the scope was looking down at the floor earlier. So he can set that to anything with no picture proof of what he's doing there. That means nothing to me. I can't really see scope, even though it looks like the hairs are below. Because remember that one rant he did the other day? There was across the lake. That was also the opposite way round. They imagined that the hair was below the target.
Is this 1 mile across or a half mile?
I
can't
don't know.
remember.
It says 1,000. I think the precisely leveled theodolite occupying Cooper. 1,613 meters above the spike. What?
What? No, 1.6.
1.6. Yeah.
Oh, right.
You know, you've probably seen some videos of people doing.
Oh,
lake
it's
tests
73,
along, you know,
11 feet away.
laser
It's over.
tests, you know,
Yeah, 700. So that's a fair bit.
It's about a mile and a half.
Yeah.
And if you look at the degrees there, I mean, how much drop is that over about a mile? That's a problem too. I don't think that would match a heliocentric model.
Well, I can't even see the target on the other side, so I don't know. We maybe get something a bit
plus
better in a
gigantic
minute.
lakes with a lot of waves and this and that. You could do the same thing on a 1 to 2 mile long lake that's nice and calm. You don't have to go 10 and 20 miles. I mean,
Rodney, do you ever look that
you'll
far?
start to see the result.
Yeah. Have you ever?
Rodney, do you?
Not in one shot, no.
Why would anybody do that right there?
I'll make it look like Earth curve, I guess. I don't know.
I mean, are they demonstrating reciprocal leveling here, or
No,
Are they-
no, not at all.
they're going beyond the limits of the instrument, or what's going on?
Yeah, even with an auto level, I'm not familiar with theodolites. It's not something that we use. But with an auto level, even a 1 mile shot is, that's kind of pushing it. I mean, you could probably do one, but anything beyond that, you're not going to get any accurate readings at all.
Yeah, when you see the specs and the manual on these devices, they talk about some really long distances, but aren't they talking about measuring your the distance away from you, like an angular? With the crosshairs, you're able to determine the distance you are from an object, and you can do that over a pretty far distance, right? Maybe a couple, 3 miles. But as far as being accurate for vertical, doing differential leveling, don't you need to stay within, 250 feet, 300 feet?
Like 300 feet.
Yeah.
Yeah, it's like we did at the weekend. In order to be able to see anything, to read it, you need to be able to read a number accurately. And that number that you're reading accurately all depends on what you can actually see through the scope. If you can't see it through the scope, then you can't read a number, can you?
No.
And I would have to say that for me, being able to measure it at an accuracy that I would be happy with, like you say, 300 feet, 100 meters.
Yeah, it was interesting looking at that rod out there. You know, we're like, I can't quite see it. You know, he came back in a little bit closer, and we were like, yeah, that's clear right there. We can see that.
Yeah,
that's a good example.
Yeah, the optics on the camera, obviously, on the mobile phone, take it away. So I'm guessing that's what he's doing, and because of the very dark black ring that he's got round there, I don't know. Like you saw us trying to get pictures to get these dark rings around it. I don't know. Do they have cameras within them? Rodney, have you ever seen anything like that? Because that picture would be quite hard for us to get.
I mean, some models of theodolites have the ability to take photographs or images, yeah, but
that'd be good. You ready to carry on?
Yeah, sure.
Results of this in short distances. I did see the same thing on the shorter distance in my first lake test over on Union Lake. It's just a smaller amount, that's all. Anyway, continuing on, I have a zoomed in picture for you to see. And I've moved my crosshair over a little bit so you can see the target. There's the horizontal crosshair. And it's set here on the 0.1 side, on the eastern side. It is set at the same height as that target is, set above the spike over there.
Look at those miraging effects.
Well, I'd say if that's the target, and if the target was the center height, you've got about, I don't know, they're quite big, them targets, right, Rodney? You're about 12 inches, about a foot square, would you say, or bigger?
It's probably about a foot square.
Yeah. So that hair there is, so you've got 6 inches from the center to the top, and then you've got, I don't know, another 12 inches to the hair. I mean, that's quite a lot for it to be out, considering
if it's going up, the 8 inches per mile squared.
Yeah, but I would have to say that there is possibly 20 plus inches above.
Yeah, especially for aiming center mass. So he'd be like, that'd be way higher than the 8 inches. Or like 12 inches, whatever they'd go by.
Yeah,
that's like double.
You're not, I wouldn't be happy with it's definitely lower. Job done. Well done. Good job, me. Look.
Yeah, you have to count the amount of clicks that you moved, and then take a measurement someplace else, and then compare the two objects. What the range is there?
Yeah. Well, like I say, what would we be looking if we're looking at 73? It's half a 73, 30, 40 foot tree that there. 30, like 35.
I also noticed he made a point to say they were both at the same elevation on either side of the lake, but just from what he showed of his process, that's probably not actually true. Unless he did something off camera that we didn't see to get actual elevations and actual accurate instrument heights. He started with a bad baseline, so anything after that is just going to be off. Any other little errors are going to add to it.
Yeah, and the fact that we don't see what this is. This is just a crosshair on a picture somewhere. There's nothing shown of the setting up the level of the theodolite, and showing us where these crosshairs are or anything.
I'd like to see his actual process. I don't know if he has videos where he goes through all of that, but
yeah, that would be nice, wouldn't it, to go along with this? If you're going to use this as proof of something, a perfectly flat level lake. I carry on.
Yeah, but he never.
Go on.
He never actually says, it's all implied when you think about it.
It could just be implying that he did a poor job on his setup.
Well, so you keep offering. Jesse, you can come for a talk and explain to us what you were doing. As yet, we don't seem to get it. But we'll see.
You can't get away from it. There it is. So moving on. And by the way, I'm going to go ahead and also indicate that I've measured 6 sets of zenith angles from 1 to 2, and here are the results with the precisions out of that set of measurements. So then I
look again. So then he measured another one on another diagonal angle. But it's nearly the same as what he got with the other diagonal angle. I really don't know. Could this be the target then? Looks like it's on a different. I think it was on a black roller setup earlier. But this definitely looks like the target.
Do the same thing. Now I'm going to move my theodolite across the water, and I'm going to leave the target here at point 1, and I'll move the theodolite over to point 2. And again, going for the same height to do the same thing again, so that we get near real-time reciprocal zenith angles.
You see, going for reciprocal.
This is called.
Lovely.
And there we go. So I'm just recording all this for you to see. And again, now I'm set up at point 2, looking back at 1. Once again, I've set the telescope to be horizontal. And zooming in, you can see that the crosshair is over top of the target.
So he's gone from both sides, Rodney. And he's found out that it drops on both sides. So I'm guessing it tilts away from wherever he puts his theodolite. Isn't that amazing?
Yeah, that's pretty amazing. That's a lot of tilt over that short of a distance.
For it to be following his theodolite. That's absolutely amazing, Jesse. I mean, how can you come to that conclusion and not go, perhaps my thing isn't quite right? I mean, how can you logically have a drop from both sides?
Yeah, I mean, with the way he set this up, the only thing he could really even do is, maybe determine the difference in elevation from one side of the lake to the other.
Of the water. The water.
Right, over the level water, yeah.
Well, we'll carry on. He might be able to pull this back. You never know.
There you go. So, from one end of the line to the other, and from the other side of the line back, we're seeing the same thing. Draw your own conclusions.
There you go. Draw your own conclusions. So you're right.
Yeah.
He's not telling you. He's just saying.
He's just kind of telling you. He's not really telling you. Yeah.
He's leaving it up to you.
Accurate. I'm sorry, I didn't interrupt.
No, go ahead.
I was going to say, he kept throwing out the term reciprocal leveling, but you can't do that with just 2 points.
Oh, did he say reciprocal?
Yeah, he did. He was talking about his zenith angles and saying near as possible current time reciprocal. He said because he's moved his level from one side to the other, right? So he is actually doing reciprocal leveling. But I would suggest the idea of reciprocal leveling is to even out the two to make a straight line.
Yeah. And Rodney, what did you just say? You can't do reciprocal with just 2 points? Is that what you just said?
Yeah, that's just going to give you a reading on the difference in elevation between those 2 points.
What would you do?
That's not reciprocal leveling, though. Reciprocal leveling would be, if you're carrying a line or doing a traveler's loop. Just say if I were going to set a benchmark, for example, you would need a minimum of at least 3 points to do that. One of them needs to be a known control point as well. You can't just hammer a mag nail into the ground and put a measuring stick on a rock next to it to get any. That's not going to be a good starting point for one. I'm not sure why he didn't just use a known benchmark. But yeah,
what I always
you need at least 3 shots to get accurate results.
do. They ever take perspective into account when you're doing these levels with the theodolite?
Not really, no. It's not something the surveyor would think about.
Well, other than the built-in perspective compression that's within the Stadia hairs, which is one of the tests that we will need to do. So can you see these lines here? Is that wide awake? Was it? See these?
Yeah, I see the lines.
Right. Well, they're Stadia hairs, and these are at a ratio of 1 to 100. So whatever distance you have in the distance, however far away, and you can fit in between these 2 hairs, and you can then times it by 100, and you will have a distance of how far away it is. So you can do sort of distance finding if you can know the distance between either the center and the top, or preferably between the 2 full hairs. But that is the perspective compression that you see naturally. We're yet to find out what happens over a great distance, because it's pretty obvious that something happens. We just don't know what yet. But that's what these hairs are there for, and these ones, it's got side hairs on this one as well, so you can do it from side to side.
Do you need to know the height of where you're shooting? Obviously.
Yeah,
what are the variables you need?
Yeah, you need to know the size of the object that you are looking at, and you need to be able to measure it within these hairs. These are normally at a ratio of 1 to 100, like I say. It's easier to show you on a different one, because these people won't show you how to do that, because they don't want this perspective compression to be shown as a thing.
Yeah, they don't like that at all.
In other words, in order to determine the distance, you have to know, let's say, the size of the car from top to bottom. Is that what you're saying?
Well, no. See, the distance between these hairs here, the top one and the bottom one. Now, they are at a ratio of 1 to 100. So, let's say in the distance, I'm holding my measuring rod, the full rod, extended, and it's 5 meters tall. Now, if that 5 meters went from here, the bottom, to the top, then you would times it by 100, and you would be able to know that where I was stood was 500 meters away, because the ratio of 1 to 100, right?
Beautiful.
But you have to know you have to know the size of the thing, and you have to get it to fill these hairs. I'm guessing you could probably do some sort of maths to work out how far something was on a little bit, but it's not going to be that accurate, and it's never exactly accurate, right? You wouldn't be able to mark that to a millimeter or anything. But I mean, from what we've tested so far, at 300 meters, you can get the half measurement. We got 1.5 meters from the center to the top when we tested it the other day, and that was 300 meters. So it's ish accurate. let's say, up to that distance. We'll see how far we can get in the future.
Understood. Very, very simple explanation. You need one guy on one side and one guy on the other side. You take the measurement and you know the stadia by 100 and you measure the distance.
Yeah.
Got it. Thank you.
No problem. We'll do a video or something showing that, hopefully. Over one of the tests that we do over the weekend, we'll try and show that.
From the other side of the line back, we're seeing the same thing. You know, draw your own conclusions.
Draw your own conclusions.
So, and again, 6 sets of zenith angles. Here we go. There's the result.
Always
All of this
drops.
is tabulated down at the bottom. I will leave a link to this blog in the video description box.
Have you seen these things, Rodney? These is
Looks like a receiver.
GPS.
Yeah, GPS receiver.
Yeah.
Rodney, what would you do with 6 sets of zenith angles?
I just want to make sure I understand what he means by zenith angles first. Is he talking about like zenith angle to the sun? Is that what he's referring to? Or?
No. He's talking of a zenith angle to below the horizontal. It's a way of them to get a little bit more than the horizontal. Because if you notice, they're always just over 90. So obviously 90 would be horizontal. And then
vertical?
The extra bit is the drop.
Is that how they end up with the triangles with more than 180 degrees?
No, this is just the line. This is just the tilt. See, I think what they do here is like, instead of measuring like we would with a measuring rod and coming up with a number and like an obvious drop, what these guys like to do, they like to turn that into this 33 seconds, 33 minutes, 50 seconds. They turn that into the drop, the distance number into an angle. And it can confuse people. And I'm guessing it has done for a few years because he's obviously got away with it and nobody's called him on it before.
Just to be completely honest, the term zenith angle is not something I've ever heard or had to use in surveying.
No.
And as far as tilt, the only tilt that we ever talk about is the tilt of your rod. If you're, we use GPS, Topcon Hyper HR is the model that we use, and there's a setting in there that will kind of auto adjust for errors in the tilt. So if you don't have your rod plumb, say if you're making a shot where you have to tilt the rod, 5 or 10 degrees, it will adjust for that tilt and correct it. But other than that, I've never heard the term tilt or zenith angles used at all.
I don't see how you can measure anything that's not vertical. It's not a 90-degree vertical zenith. It's not correct. It doesn't make any sense to me at all.
But that's what I said. The unit that I use will auto-correct for that if you have your tilt set up that way and calibrated correctly. Because some shots you cannot have the rod perfectly vertical. I mean, you can't have it level all the time. Some shots, the point that you have to put the rod on is going to be at a place where you have to tilt the rod. So not all systems will adjust for that, though. I mean, not all GPS units will, but the one that I have does. It'll adjust for up to 15 degrees of tilt if it's calibrated correctly. That's the big thing. But yeah, other than that, I don't know what they're talking about with zenith angles and tilt. It's not something that we use or talk about. All we do is work with elevations and grade.
With numbers as well, with either inches or centimeters and meters. Do you? What unit do you use?
We use feet and tenths.
Yeah, tenths of feet. Call them American feet.
Yeah, the coordinate system is in feet. Just north, east, and elevation.
Yeah, can I ask a question, please? I just wondered what what the maximum distance you would use, like a sight level, or we call a Cowley level, or an auto level. If you're familiar with that tool, what would be the furthest you'd be happy with being accurate with that? That's a Rodney. Sorry.
The furthest shot I've done with an auto level was about roughly a mile. Like I said, but that's anything beyond that would be really pushing it. With the heat and the humidity where I live, even at a mile, I was out. I want to say about 200s, but there was a lot of refraction and just not good conditions for a long distance observation.
Optical that you could look for.
Sorry, I didn't catch that.
Yeah, you broke up a bit there, Spark.
Sorry, so is that using? I said an auto level. I meant like one that is optical that you look through.
Yeah, it uses opticals as a scope.
Yeah. No, I didn't know.
Actually, what sort of a scope have you got on yours? On your auto level?
32.
Is it?
32 times.
Have you heard of a better one with a better scope?
There may be. I've never looked, to be honest.
Do you reckon it'd be interesting? Because we were thinking that the other day. Like, if you could have a bigger scope, you could see a lot further, couldn't you? But do you reckon it would be more accurate or not? I don't. I think it's the optics of looking through it over a distance that makes it maybe the limiting factor of the 32 times scope.
Yeah, probably so, because the longer you try to go in one shot, the harder it's going to be.
Are you familiar with like the rotary laser levels as well?
Laser levels? Yeah.
Yeah. And have you ever used them over anything more than 100 meters, 200 meters?
No, probably nothing over about 300 feet.
Yeah, about 100 meters.
Yeah.
Okay.
Yeah, we're still testing that one, Spot.
Yeah.
Right.
Yeah.
Are we ready to carry on? We're only halfway through this.
Sorry.
Yeah.
Oh, yes, sure, carry on.
Okay, then I thought, well, I'm going to just take a break now. You noticed in the first test I did on Union Lake, I had the GNSS receivers running simultaneously while I measured the zenith angles. That was a good method. This time I wanted to do it and have them be separated because I wanted you to see that these GNSS observations have really nothing to do with the zenith angle results that I'm getting. So I actually did them separate. Okay. So here I took a break from the zenith angles and I set up 2 GNSS receivers to log multi-constellation, multi-frequency, and what we're talking about here is it is not just GPS, it's GLONASS, which is the Russian system, and GPS combined. There might even be some Galileo in there, but there's still not very many of those satellites up there yet. But anyway, I've got 45 minutes of simultaneous recording of data at both ends of the line, which can then be post-processed to solve for the vector between the 2 points.
Right. Post-processing, right, is data manipulation after the fact. Would I be correct in saying that?
It sounds like that's what he's trying to say, yeah.
And so he's putting up 2 GPS units, and it looks like he's got them on the nails, right? So is that what they're meant to do? Is that, is that GPS unit, both of the 2 GPS units, measuring the top of that nail position?
Yeah, they would give you the elevation along with the northing and easting position of the nail. I mean, not with his, because he just drove a random nail into the ground, but that's what they would normally do.
Yeah. So, as he's doing this, like he said, the Galileo satellite system and all of that, they're all floating about in the imaginary space above 50 odd kilometers, I've heard, or maybe even further than that, 12,000 miles, I've heard at some point. They're floating around, and they are, how accurate would that be to the point of the nail head? Because he was measuring to a millimeter at 60 mil.
You could be accurate to within a couple of hundreds.
The position of the nail head?
Yeah.
Okay. From satellites, or do they get...
I mean, I would say satellites in air quotes, but the biggest, well, in the area I live in, the biggest satellite that we use is actually just a transmitter, and it's located on top of one of the big Saturn V rockets at the Space and Rocket Center. It's got like a 100-mile range. So normally, if you're within 100 miles of that, and you're using, because we use a GNS, that's what the TopCon HR is. But yeah, if you're within 100 miles of that receiver in my area, that's what you're connecting to.
And would it be triangulating between, as many of those different positions that it can find? And yes, using all of those over the 45 minutes or whatever, keep sending signals in order to slowly refine it to get more and more accurate positions, all within a data stream that he then post-processes.
I mean, the results are pretty accurate from the time you set it up. You don't have to wait 45 minutes for it to do all these triangulations. I mean, it's pretty much instant.
Oh, well, remember, this is 3 years ago, so it might have been in the early stages, but 45 minutes he said it was doing it for.
Yeah.
Bev, just to mention something. Sorry, Rod.
No, go ahead.
GPS satellites are not in geostationary orbit.
Mm-hmm.
Just to clarify that, they move.
Yeah.
Orbit.
I've never actually had somebody explain to me how the process for the imaginary satellites work. I mean, the way Rodney just showed for the triangulation of the land points works perfectly. The imaginary satellite thing is a completely different process, I would imagine.
They're moving, so they're going to start telling you about time dilation and mathematics and all this kind of bull.
Yep. Yeah, 3 atomic clocks each in.
Yep.
I'm pretty sure your position is established through the core system. It has to be. That's what's going on. It's the CORS system.
Yeah. It's just a triangulation of land-based things, I think. That's the only way it can work to give an accurate vertical height, at least, anyway. I would imagine they come up with a couple of different grades, don't they? They say that the horizontal position, or like your position on the land on the horizontal plane, is much more accurate than the vertical.
Apparently they're at 55 degrees inclination, and they orbit every 12 hours at 10,900 nautical miles.
10,900. I'll have to try and remember that.
Yep. 20,200 kilometers.
Yeah. I heard that they have an accuracy of about 10 meters.
I've heard greater than that, the military ones, but that's what they say, up to like very, very close. Almost inches, they say. The military, because there's two applications. There's the one we use, and then there's the military one.
Interesting. For another day. But I like the inclusion of these GPS things would you use that sort of a thing rather than the theodolite, Rodney?
Like I said before, we don't even use a theodolite. We work pretty much strictly with GPS and auto levels and grade rods.
Right. So would you like this setup? It looks like he's got two GPS units either side. Would you do that, or would you just use the GPS to give you a position?
We just use a single receiver with a base station. So we'll set either a temporary or a permanent base station, and it'll all work from that. Right.
I'm just trying to get. He's used the theodolite, so let's put an auto level there, right? He has done the auto level test. But could you then do away with your auto level and just put 2 GPS units and do what he seems to say he's doing here? And just leave them to gather data and then gain anything from just the GPS data?
Well, I mean, if you had a base station and 2 receivers, set at different points, you could get a, kind of a triangulation between those, I guess.
Yeah.
But like I said, we don't use a 2 receiver setup, so.
Again, well, okay then.
And I can't read the writing there, so I don't know what he's actually saying that he's trying to do.
He's just said he's fixed. He puts the GNSS receiver was set up at a fixed height of 2 meters above the spike to collect carrier phase raw data at a 1-second rate. These GNSS receivers log data simultaneously for 45 minutes in order to post-process the vector between the points later.
Yeah, so that must be older equipment, because ours, what I use, is instantaneous. It doesn't get more accurate the longer it's set up.
Okay. Well, it might have changed. Jesse, we're still ready for you to come and talk.
So once that was done, I decided to then set up the target and the theodolite again for a completely separate, independent set of observations. So here we are, putting the target precisely leveled over 0.2 again, and measuring the height. This time it's an absolutely different height.
Yeah, still as badly measured.
Spike, which is 60 millimeters above the water. And here we have the target now set at a height of 1588 meters above the spike, aiming back at 0.1.
It's a nail there. Oh no, sorry, another nail.
Now over here, we see that it's quite easy to make a mistake, even when you're taking great care. So I'm reporting it. I'll let you see it, and I will document what happened. Up here you can see that I measured 1.43.
Oh, he showed it.
Yeah, that's badly.
I set this thing at 1.34.
And this one nearly looks vertical as well, so I'm not so sure what's going on. It looks like 1.341.2, so perhaps.
And I'm flying. I'm doing this all by myself, so I don't have a note keeper. I don't have an observer. Usually a survey party has several people involved. I'm doing this all by myself, and bam, here's a mistake, 1340, and I didn't catch it. And I literally measured a whole set of zenith angles at the incorrect height. All right. Now, when I took this picture, I should have known immediately, but I'm flying here trying to get this done, and oh well. So yeah.
So can you see these lines here? It's as though, I don't know. Maybe, I don't know. Maybe he was different, but Rodney, I don't know about these measurements on the side here and what he's doing.
It seems like he's trying to set the height of his instrument, or determine the height of his instrument.
Yeah.
But like I said, that's not the way I would ever do it.
No.
Our results have to be pretty accurate. Like I said, usually to within no more than 500. So we can go a tenth sometimes.
Yeah. Yeah. Well, yeah, we'll carry on.
I recorded, and I report them here. Hey, for what it's worth, here's these 6 zenith angles measured at this different height, which is useful. You could look at the difference, compute the difference in the height, and do some analysis of that. I didn't bother to do that. I'm just reporting it here. Maybe somebody else will look at it. But here it is. So I'm saying here, as discouraging as it was, and let me tell you, when I found that this happened, I just looked at the water and thought, I wonder if I have enough information to just leave right now, because it was a bummer, and but I persevered. I said, no, you got to keep going. You need this second set. So I broke it all down, reset it up, and got it back at 1430. And
just 1 millimeter.
So this is what you're going to see next are the pictures where the instrument is set at the correct height.
Before I forget.
You right?
Oh yeah, before I forget, I just wanted to say, he said something a minute ago about you could do something to determine the difference in height, something along those lines, but I didn't bother to do that. That's kind of the whole point. I mean, if you're not doing that, what are you doing? I just wanted to throw that out there. That's really the whole point of doing something like that. So why would you not bother to do it?
Yeah, it's all about the elevation, right? That's it. And have you ever measured elevation in an angular form?
Well, not at an angle, no.
No.
Measure elevation on a horizontal to a vertical.
Thanks.
Okay, sorry, I didn't mean to interrupt. I just wanted to throw that out there before I forgot. I just caught that comment.
Thanks. Any time, right? Yeah.
I set the telescope to be 90 degrees, zenith angle of 90 degrees, which means that this horizontal crosshair is the horizontal plane extended from where I'm observing from.
See, a horizontal plane extended from where he was observing from.
Mm-hmm. He's about the only one that'll ever say that.
Yeah. I bet he'd struggle to say that nowadays.
I bet. I know.
That's exactly what it is.
That's exactly what it is.
And so, just as before, we are seeing that the horizontal crosshair is over the target. Okay? And there's a close-up of that for you to see. And then I measured my 6 sets of zenith angles again. Report them here.
Again? I'm going to have to find out if... remind me if we ever talk to Jesse, if he ever comes to talk. I need to know what the deal is with measuring like this.
Measuring at an angle?
Yeah.
Okay. I'll write that down.
Yeah.
Jesse, why do you measure at an angle? Okay. I got it.
It's the tilt.
Once again, now I'm going to prepare that the target is going to be set at the same height, and I'm going to move the theodolite across the water to point 2. So here's the target all ready to go.
It's just going back again and doing the same thing, right? He's already done it once.
At this new height of 1.588 above the spike. Spike's 60 millimeters above the water. Okay, so here's the telescope now set up at point 2, same height. And looking back, We have a picture zoomed
Yeah,
in
look at it.
showing you that the
Below it again.
crosshair is once again above the target over on point 1.
Drops. Always drops away from
That's all
Jesse.
stated here. Then I actually record zenith angles directly to the target. 6 sets. There's the standard deviation. There's the standard error of the mean. Okay, after the second set of zenith angles were measured, I closed out the day by just setting up the GNSS receivers once again on both sides of the lake and recorded 55 minutes of simultaneous data. It was about 20 minutes till 1 o'clock. And it
Oh,
went for
God.
4 minutes.
Here we
44
go.
minutes.
Yeah.
And then, of course, I did the next set of zenith angles. And then after that, at nearly 4 o'clock, I started it up again on both sides and recorded 55 minutes of data.
Done like 4 hours work there.
And so here you are.
From
It's
one side
from 1
of the
to
lake
2,
to the
both
other.
times. I report the RMS out of the software, the number of satellites that were tracked,
Found some
DX, DY, DZ,
19 satellites
vector
total.
length. We also have the ellipsoid distance and the delta ellipsoid height and the
Ellipsoid
azimuth.
distance.
Okay. Now, I also went and got some data off of the internet for this NGS core station. These are continually operating reference stations. that
There
we go and
it
get.
is. I told you guys.
What?
Yeah.
Is that the
He's referring to the continuously operating reference system.
Yeah, yeah.
They're
that's-
ground stations.
Yeah.
I have a map for that.
Yeah, it must be separate to the satellites, right? It must receives 2 different sets of data, right? Because this one up here is satellite, and this one isn't satellite. Definitely not satellite, right? These
Yeah.
base stations are ground based that he's talking about on this bit now, right?
I don't know about the satellites.
And it does say here adjusted grid coordinates. Adjusted
State plane grid coordinates and geodetic latitude and longitude.
Mm.
So it's got grid coordinates. Go ahead, Rodney.
Oh, sorry, I didn't mean to interrupt. Go ahead.
No,
I was just going to say that the state plane system is what his GPS is actually working off of. So it's in a Cartesian coordinate system, so he'd have to convert it over to latitude and longitude. It looks like that's what he's done there.
Yeah, that be the adjusted part of it.
I'm assuming so, that when he did the conversion from state plane to latitude and longitude. Because any state plane coordinates, they can all be converted over to latitude and longitude. That's how they, I guess, integrate it with the WGS 84 model.
Yeah, they take the state plane and then turn it into a globe. Am I making an assumption there? Or?
No, that's 100% correct.
Okay.
Yeah, he's got the ellipsoid height, distance or whatever there as well. So, they're already playing on that. That's not playing and adjusting. This is the good bit coming up there, though.
Yourself to use and post-process from, and that's what I did, and held it fixed. And the first thing you get, these are kind of switched out of order. The first thing you end up with are the adjusted latitudes and longitudes, the geodetic coordinates, and the ellipsoid height. And I held that station fixed, the core station. And then those get projected to state plane coordinates. That's what I did here in U.S. survey feet. All right.
I think he
And
just
the
said
next
that
thing
backwards.
He did. I was just about to say that. He said it backwards.
He said that these were backwards, but did he get it backwards in explaining that these were backwards?
You start with state plane and then convert to latitude and longitude, not the other way around.
Yeah.
He said the total opposite. I think he may have did that on purpose.
Yeah, I think so as well. We go back over that because nicely spotted.
And I held that station fixed, the core station. And then those get projected to state plane coordinates.
Yeah.
Yeah.
So the
Yeah,
geodetic
backwards.
get projected to the state plane.
Fine. I had $1 million to bet whether this guy was really a surveyor or not, I think I would have to bet he's not.
Yeah.
I'm just going to say, and I hate to call someone a liar, but that would have to be an outright lie on his part, because if he uses a GNSS GPS receiver like that, same kind I use, I don't see how he could say it goes from latitude and longitude to state plane, because it's the coordinates that it would even show on his, on his tablet would be in state plane coordinates, and it would take some work on his part to convert those over to latitude and longitude. So he has not the way it goes.
Yeah, the state plane coordinates are what's measured. The geodetic latitude and longitude is what's calculated.
Yeah, I've got somebody.
How you could get that backwards on accident.
I've got somebody in the chat that's saying Jesse's still trying to find the curve. No, Jesse is not looking for the curve, because Jesse knows it's a tilt. You can't measure a curve with these instruments. You can only measure a tilt from one point to another.
I would like to jump in a little bit and also agree. There's no way he messed that up, like mixed it up. No surveyor, you know what I'm saying, unless he's doing it on purpose. That wasn't a sleight of, just mistakenly saying it the wrong way. He knows for a fact, right? He knows that. There's no way if he's a surveyor he doesn't know that.
Yeah, he would have to.
Yep. He couldn't use his instruments if he didn't in the first place.
And
now, you do have settings on the newer equipment that will translate it for you. But he would know this, right? He knows the settings. He knows what the default is. Basic. I'm not a surveyor, right? And I know these things. That's how basic it is.
Yeah, the default is the network RF setting and a state plane.
Right. Right, state plane. Right, exactly. That's the default on all. You have to actually change it to translate it to anything else. And like he says, it takes work to do that. It takes knowledge to know that it's the default, first of all, and how to change it. And you're trained on that as a surveyor on how to use the equipment, but you would know this for sure, like 100%.
Yeah, you would. And there's not really any reason other than one that I've ever had. I've had to actually convert to latitude and longitude. The only time I had to do that was I had a set of coordinates, state plane coordinates, to a known control point. Had a really hard time finding it and wasn't able to. So, I did the conversion, got the latitude and the longitude, and just plugged that into my Google Maps. So, it took me to where the control point was, or pretty close to it.
So it would show you where it was on.
Yeah, that's the only reason you would have to do the conversion, is if you wanted to have GPS coordinates that you could use in a, Google Maps or something like that.
See, Jesse, and all of them, I've tried to pin them down on using this equipment over long distance and whatever, and it took people like you and I and others questioning for a year now, like, to get them to actually come out and say. They wouldn't freely offer the information that when we were taking these shots to buildings over water and measuring down all that wasn't accurate, and it could be accurate by like many feet, 20 or more, right? And they're just disingenuous in that way. Like, they should tell the audience these things. If they have nothing to hide, they would be very open in these things, and they're not. That's what makes me think they're being a little disingenuous or have an agenda or whatever it may be. So who knows?
Yeah, it's good having you guys here, there, because that's a nice spot. But people to be watching out for things like this, because he did flip it around completely, as if to say that these measurements were made using the geodetic coordinates and then transferred to a plane system, which that does sound very disingenuous to me, if it's done the exact opposite way round.
Well, if he's using the same equipment that I've seen and used and been acquainted with, and that's not the way it is. No, he might have something else or where the default is different, but
Could be.
none that I know of.
Sorry. I was just saying, from what I saw, it looked like he was using a TopCon system, an older model, but definitely a TopCon. So
Yeah, the video is three years old, so I mean we'll give him benefit of the doubt for aged and new tech that's come around nowadays. I would imagine that 3 years old tech with this sort of stuff is pretty old, right? New system.
Probably pretty old, but it still would have worked on the state plane system because that's what's used.
Yeah.
Yeah.
So
there's no need anytime in any practical use for anything other than state plane.
Has anyone here actually had a word with Jesse about this, the system and how they use it?
He's not around anymore. I don't know what he's doing now.
Yeah, it's just Rakia was saying that we've been pushing them, but I mean the people that we've been talking to mainly is Pura George, and we've not really had much of a conversation with any of the others. So I've had a short conversation with Jesse over on Jose's, but since then they seem to have gone into hiding.
I'm not sure if they're aware that we're right here on MEUK's Discord server pretty much every single day. They could just drop in and have a chat.
Well, I mean, it would be nice to have one of the so-called claimed curve tilt measuring surveyors to come for a chat. I mean, they can't be that shy. I mean, they've supposedly measured these things. Or do you think he might just be leaving it up to people's imaginations and letting them, people with their imaginations?
I think that's what he said. Yeah.
Carry on for the good stuff's coming.
That's what I did here in U.S. survey feet. All right. And the next thing I'm reporting is the tabulation of my observed zenith angles being compared to what you would compute using this formula, from both ends of the lines of using the latitudes and longitudes. Whether you get those values from Google Earth, you could. You'd probably get very similar results. It's on a sphere, and so it's just it's a rough approximation, really.
It's a rough approximation, really, because this is the things. I don't know if you can read this. It says, if this angle's cos...
Cosine.
I don't know what you call it.
Yes, cosine.
Yeah, that's the cos, but I mean this little angle, like it's the cos of the angle is the sine of the angle, and the formula. It says if that angle is the Earth central angle of the arc between the 2 points. Right, so this angle here is this angle between these two verticals. And that's what he's computing from here. Now,
it's all shite. Yeah.
He's measured this angle here is the drop from either side. This is fantastic maths. This here with these perpendiculars, like I've been saying. This is not Euclidean geometry. Euclidean geometry would disprove this, because this angle here, this is a horizontal, and this is meeting a vertical. Well, this one here, horizontal, vertical, that's not perpendicular. So, this, for me, is probably one of the most disingenuous things that I see on this thing.
Oh, this is the absolute worst, man. He's talking about presupposed Earth curve and using Google Earth to determine your, vertical. I mean, he's out there he knows what vertical is, but he's trying to pretend like they're tilting away. And the angle at which they tilt away over such a short distance would make the size of the ball Earth incredibly tiny, if that's what he's saying. But, he's so ambiguous about what he's really trying to tell you there.
He does actually have this here now. I don't know what this is, because he's got the little star asterisks 1 and 2. These are both computed results, or decimal feet.
8 inches.
At the standpoint. Well, he's got the curve drop here of 1.28.
Yeah.
Well, that's decimal feet.
Well, it depends on which
from
type
the
of glove head he
horizontal
is.
plane at the standpoint. Well, that's 1.2 feet. 8 inches. It was half a mile.
Yeah, it just depends on which type of globe head he is. Is he a curve guy? Is he a drop guy? Is he a hump guy? Is he a slope guy?
Well, he's got curve here. So this is
Okay.
before Belu's told him.
Yeah.
Get rid of the curve. Let's have a tilt. But look,
Yeah.
he's measured it, right? I mean, this is computed. I mean, it does say computed. It doesn't
Right.
say measured. But that gives us something to go for. Jesse says it's there. From the horizontal, look, computed results are decimal feet in inches down from horizontal plane at standpoint.
So he is going, yeah.
Yeah, there's definitely a drop in the down direction from the horizontal plane at your standpoint. And he said that the horizontal plane was extended outwards. So that's all we've got to do is, he's helping us really with this. Thanks, Jesse. But we could do with having a chat still. Anybody else want to say anything before we carry on?
Oh, yeah, I just want to say one thing. It seems like they're just they're measuring a change in elevation and then just calling it tilt. To me, it seems like that's what they're doing.
It's not really elevation over that distance, so.
Yeah, it seems to me they're just looking at things over a distance.
Oh, they're not even taking measurements?
Well, it's an angular measurement. All of this is computed. These numbers here are computed. They're the only time really you saw him measuring anything was the height of his instrument and the height of the nail.
Yeah. And then his horizontal crosshairs appear to be higher than the target for whatever reason. Maybe it's not horizontal, but even if it was horizontal over that distance of 1.38 miles, you're going to have sinking due to atmospheric, water vapor. You're going to have, perspective compression. You're going to have, the angular size is going to be incredibly small.
Oh, well, let's not predict that, right? Because that still gives us something for us to test. We just need to keep finding lakes and do exactly this, but with an auto level, and we'll get the results for ourselves. Hopefully. Yeah. It does. It gives us something to look at to work out how this is actually happening. It might turn out that he's he was wrong all along. We never know. Or he might be leaving it to your imagination, and you might just be imagining what's happening. That could be the case, couldn't it?
I think that's what the globe is all about. It's all about imagination. Yeah.
Yeah, I don't think there's much left of this.
Close enough and good enough for what we're discussing here.
Close enough and good enough.
Whether or not there's so-called missing curvature. And the zenith angles, when you sum these, you're looking at the difference. In other words, you're not getting 180 degrees, you're getting something over 180 degrees, which is indicating this tilt. And so I did it twice. I did it, earlier in the morning, and then I did it later in the afternoon. I have variation here. It's not a huge amount. It's basically 4 seconds. It's 11-second variation. You're going to have that. And if I might get 1 minute and 4 seconds. Who knows? You're going to have variation in measurement. And that's why we use statistics to compute the precision of the result. And as many times as you repeat a measurement.
Is that right, Rodney? You use statistics to compute the accuracy, or do you just keep repeating it if you're not happy?
No, we use math to compute the accuracy.
You will have variation at the last decimal place or at the last significant digit. It's going to happen. That's pretty standard in any science. So I'm reporting that, and then this is the computation.
Science? Is this... Would anybody else class that as science? Measuring angles?
Cause and effect of angles? I wouldn't
know. Is it because he keeps getting different results and he thinks that's science, perhaps? I don't know. Again, I'm up for learning about that, Jesse.
You can see that, I'm within reason here. We have very good comparison here. And then I show you the miles and the curve drop using that 8 inches times the mile squared formula. But I'm also showing you a column of trig computed values using my zenith angles. And we are within reason. We're within the magnitude of a foot, let's say. If we want to round this off to a foot, then we have good agreement, and that would be reasonable for this conversation. And when we're talking about 7,000 feet, basically we're looking at about a foot. You can round it off, and that's what we're doing here. This is not high precision construction layout. You wouldn't try to lay out a curb or a pipe 7,000 feet away. That's just not done. So let's be real about what I'm showing you here. And
did you get that? This isn't precision.
Nah, it's just he's wrong every time, and he takes all his wrong calculations and averages that to a average wrong.
Yeah.
Yeah.
That's I mean, he said it's highly precise, right? And now he's saying it's not precise.
Yeah, he did. He said both of those.
I don't get that part. That's a little over a mile, right? A mile and a quarter.
Double speak is what they do, though. I mean, they can cover all bases if they say all of the different possibilities, right?
I think what he was doing, because it is highly precise if you do it correctly. So maybe he was just saying that it is highly precise, but the way I did it is not.
I could take that. Yeah, if you don't do it this way, well, you might be able to get it more precise.
Personally,
Ronnie, would you go ahead.
Personally, perspective alone causes a drop in my eyes, in my opinion.
Yeah, I agree.
Yes, absolutely. That's the key, actually.
Would you ever do a point A to point B shot over a mile and a half?
No, not at all.
Yeah, I wouldn't either. That's my point.
I mean, you could go. The farthest I would go, maybe a half a mile. If it's just something where I had to go that distance, but never a mile or mile and a half for sure. That's ridiculous.
I just wanted to make sure you and I were on the same page. If I did, if I shot a mile, let's say, and I marked it, I would double check it 10 different ways, right? I wouldn't trust it at all because I've never done it where it's accurate. I don't think he's saying you can be accurate. I think they're just taking the averages and blah, blah, blah. That's not good enough in what I do.
Well,
now, if you're going that distance, you're going to have to take multiple shots and, back shots and fore shots and check yourself each step of the way to make sure it's accurate.
Yep.
He initially takes the 60 millimeters above the the water though. So he's obviously referencing the water in some way in order to do that. So I'm just thinking about the test we've got coming up, you know, like, and trying to reference this thing that he's got, because it's pretty similar, other than the fact that what we would have done was put an actual water level tube going from, like, we'd have put our targets up and then mark the horizontal with the auto level or whatever, you know, over that distance, and then we will get a water level and put that up to the marks. And what he's saying to me, in order he's saying that it will drop from away from the point that you're at. Is that not what he's sort of saying here? You know, like when he moved from one side to the other, the water level drops. Is that like, I'm just getting my head around it. Can I confirm that is what he's saying here?
Sounds like it.
That I can't work my head around how that could even be possible for somebody to contemplate that as being a conclusion of what's happening here. I mean, I can understand them thinking that the globe, right, it moves and it slopes away from them. But you can't have it sloping away from you and then you going to the position that it's just sloped away from you and finding the bit that you're actually at is the bit that's sloping away. I mean, your position cannot affect what happens to the water level, can it? Is that what he's asking us to do? Or is it just me the way I'm thinking about this?
The water level is changing relative to your position. What was it you said exactly?
Yeah, like he's at two positions either side of a lake, 1 mile apart. Now he's putting himself with an auto level or a theodolite, let's say. Let's call it an auto level because he's saying he's on the horizontal. And when he looks through that, the bit on the other side is lower. Right? And then he goes to that place that was lower and looks at the place he was just at to find that it's now lower.
Yeah, it's the Penrose staircase effect. You constantly go down
from you. Yeah, like, so
yeah.
You've got to feel so self-important that even the water drops to you.
That's awesome. That's a money shot right there.
It's crazy. We'll carry on anyway.
Didn't Moses already
when
do
you
that?
Yeah, Jesus walked on water. Moses split the water, and Kozlowski can control the level
Control,
of it.
yeah. Control the water in the distance.
Mm.
At my other tests that I've done, looking at buildings that are 20 miles away, 30 miles away, etc. You know, now you're talking about many, many hundreds of feet, and these videos, these flat Earth videos that are talking about that these buildings and land features should be hidden by many hundreds of feet or thousands of feet. You know, we find that that's just not the case. You set the telescope to be perpendicular to your direction of vertical where you are, and you can see many hundreds of feet of drop. It's clearly visible in the photographs. And that's really the intention behind all of these videos that I'm producing lately. And that should be understandable to anybody that's, you know, really sincerely looking at this and trying to understand this. So
Did you say
anyway,
hundreds
I'll
of
sign
feet
off
of
here.
drop?
Yeah. Yeah.
Wow.
This horizontal plane here shows over in the distance, because I think he was talking about 30 miles sighted. And to see.
Yeah, well, you got to trust his measurements. Sometimes they're right, or average the wrong stuff together, and yeah.
I'm guessing
Very, very sloppy.
as long as the stuff in the distance when you put it is below the crosshair, he'd be happy. Be like, yep, that's what I was expected. Roughly ish, you know, that'll do.
If you have questions, just reach out to me. You know,
Yeah.
as you know, I have my comments are turned off. And,
Yeah.
you know, I've really stated the reason for that is that I'm not interested in any warfare.
No, we're just after a chat,
on
Jesse.
YouTube. Everybody can type in a description box, and everybody can cop an attitude when they're not sitting right across from you. So, you know, you get a lot of nastiness, and I'm not interested really. So, if you want to talk about this, send me an email, send me a message through YouTube, and you know, I'll be happy to talk to you there.
There you go. So can we class this as a message to Jesse on YouTube? We're not after arguments or anything. We're just after learning more about surveying, maybe discussing some tests that we've got and some of your methods, Jesse.
Yeah. Come and teach us, Jesse. Show us what
Yeah.
you're doing.
Jesse's a god.
He's spoken of very highly. We've heard your name mentioned all over, Jesse. I'm sure there's lots of people can learn. Lots. Please.
Come and teach us what Belu taught you.
And subscribe to Jesse Kozlowski. I mean,
Yeah.
he needs some more. Well, that one's got 5,000 views. He's only got 1,600 subscribers, though.
Wow, popular video. I think we may have watched it quite a few times now. But I'm going to cut the YouTube live stream on this end, man. It's awesome having you guys here. You know, Rodney, Rakia, SE, Wide Awake, Bev. Awesome show.
Cutting mine.
But
Thanks for having me, man.
yeah, thank you for your input. Awesome.
Anytime, please, guys, come round and we'll
thanks for having
do
me,
a
Chris.
few more of these different surveying ones. I mean, there's a few different ones we can go over. I'm
Anytime with you, Bev.
hoping
You know
we
your
can
stuff,
get
bro.
Jesse to come round as well.
Good luck with that.
Yeah.